Good morning to all our attendees who have joined us this afternoon for the Data Processing Unit, the third pillar of the Accelerated Data Center, hosted by NVIDIA and supported by Custodio Technologies. Before we begin, a couple of housekeeping announcements. Feel free to share any questions you have in the Q&A chat box that can be found at the bottom of your screen. We will address the questions via chat during the webinar or live at the end of the webinar. Today, we have John Kim, the Director of Storage Marketing at NVIDIA Networking, as well as Alvin Ching, Director of Cybersecurity at Custodio Technologies. Right before we begin today's session, may I invite Alex Greenstein, the GM and Director of ASEAN Sales at NVIDIA Networking, to give us an opening address and welcome, please. Alex, please.
Okay, thank you, and good morning and welcome addresses. It's a good afternoon. Okay, good afternoon to some of you. It's good morning, but good afternoon, everyone. And warm welcome to this NVIDIA webinar about Data Processing Unit, or DPU in short view. The DPU is a new class programmable processor that will be joining the CPU and GPU as one of the three pillars of the computing, and will play an important role in the transition to modern data center, where data centers become the new unit of computing. This webinar is specially put together for IT managers, network and security architects, as well as those in the CTO and CISO offices across enterprises, government, institute, telcos, and cloud service providers in Southeast Asia region and extended APAC region. By the end of the webinar, you would have a learn about why the modern data center needs to be distributed and accelerated, why security is moving from the perimeter to the servers for east and west traffic, and how to use NVIDIA Bluefield DPU to accelerate your data center infrastructure and offload the infrastructure from the CPU today to the DPU. With your permission, I shall now hand it over to John Kim, the Director of Storage Marketing at NVIDIA Networking, to kickstart the webinar. Over to you, John. Please.
Alex, thank you very much. Okay, I'll go ahead and share my presentation now. All right, so as you mentioned, I'm going to talk about the DPU, or Data Processing Unit, as the third pillar of the new data center. So let me go ahead and get started. So the first thing that's driving the need for a different data center or a new architecture in the data center is the continued exponential growth of data. We see that over the years, and this is continuing even now, data is continuing to grow very quickly. It's not growing linearly, it's growing exponentially. In fact, it's doubling probably every few years. So the amount of data that we have out there, the data that must be stored and processed and analyzed, is huge. So that's one change. And then in addition, the second thing that's driving a new type of data center architecture is the increasing use of artificial intelligence and machine learning, also known as AI and ML. So in the past, AI and ML were used just by some universities and a few special companies or government agencies, and it was very specialized. People usually had a special architecture, a separate IT silo, just for their AI and ML deployments. But now, every kind of business is going to be an AI-powered business. AI and ML are going to offer analytics, better customer service, better product development, better quality control, visualization, and different benefits to pretty much every kind of business out there. So everyone needs to learn to deploy artificial intelligence and machine learning. But these models for these applications are very complex, and they use a lot of that data we talked about. The models are also getting more sophisticated and require more computing power. The challenge is that the exponential growth of data and the growth of the complexity of these AI and ML models is growing faster than the power of the CPUs. In the past, Moore's law said that CPUs would double the number of transistors and therefore double their computing power every year. And then it became every 2 years. And then it became every 5 years. Now we see that CPU performance is still growing, but growing at a much slower rate. And it can't keep up with the growth of the data or the amount of memory that applications use, or with the complexity of these new programming models for AI and ML. In fact, we see here on this chart that Moore's law is pretty much over. The CPU is now only increasing in power about 10% a year. So we can no longer just throw faster CPUs and more transistors at these problems or at this increasing amount of data, which is what we used to be able to do. Now we need a new way to accelerate analysis and compute and processing of all that data. Fortunately, there's a new technology that's been out for a while called the GPU. This initially meant graphics processing unit because it was first used for graphics, but now it's become a general processing unit because the GPU can handle many different types of parallel computing, data analytics, any sort of application that uses a lot of math or compute, visualization, graphics, simulation, virtual reality. These are all great applications for the GPU. And the good news is that the GPU power has been growing exponentially for the last 10 years. So just as the CPU power growth is slowing down, the GPU power growth, or the ability of the GPU to solve bigger problems and process more data, is still growing exponentially right now. So what this leads to is a new type of data center where we're going to have acceleration available across all parts of the data center. So on the left, we see the traditional silo data center where most of the data center runs just a CPU. And then I have some silos or some special deployments or special sections that maybe ran GPUs or had some FPGAs or some special networking, like in-network computing, like InfiniBand. But that was only run for special applications in small sections. What's going to be different is the new data center is going to have CPUs and GPUs and network acceleration across the whole data center. And any server or application that needs that acceleration will be able to get it. It's going to be container-based. It will be disaggregated, meaning that the different kinds of compute and the storage will be separated out, but then it will be composable. The different parts of this data center can be brought together on demand as needed in just the right amounts for any application. So if an application needs 5 CPUs and 1 GPU, it'll get it. If an application needs 1 CPU and 6 GPUs, you can create that instance with containers and give that application what it needs. And it's all connected by a high performance network. In fact, we see that with the new data center, it's architected similar to the cloud. So you're building private clouds, and it's designed with something that can serve thousands or millions or potentially billions of users. And applications in this data center are built on distributed microservices. So instead of having a bunch of servers, each server is dedicated to one application. Now applications are made up of many small services that run on different servers or in containers across the data center. Containers are virtual machines. And again, just the correct number of the right type of containers are assembled together to create the application. If your application suddenly needs more microservices on the database side, you can add more microservices just on the database. If you need more on the security side or more on the web side or more on the analytics or more on artificial intelligence, you can add just the components you need to expand or contract and scale up and scale down your application as you need it. The key is that there are many microservices running on different containers, on different servers, with different kinds of CPUs and GPUs across the data center. And again, they have to be coordinated and they have to be connected with a very fast, low latency network so that you can get a high performance application. So that brings us to the need of what is the third pillar and why is a DPU filling that role? So in this data center, we have the CPU, we have the GPU doing the compute for different kinds of data and different kinds of applications. But now we have the DPU, or data processing unit. And what this does is it accelerates the infrastructure. Okay? It accelerates the movement of data, the security, the different types of networking, and also other infrastructure tasks like encryption, remote management, time synchronization, and it lets you move the data more quickly. So the GPUs and CPUs get the data they need more quickly, whether it's from each other or from storage. And this data can be secured. It can be analyzed. You can get alerts. And we'll talk more about that in a few slides. But again, the key is the infrastructure of the data center is now accelerated by the data processing unit, or DPU. But what is a DPU? And what is in it? Why do I call it that? And how does it work? How does it accelerate this infrastructure? So in this type of scale-out data center with distributed applications, you typically have a lot of virtual machines or containers. And you also have software-defined infrastructure. So first, the applications are running on these VMs or containers across different machines as microservices that are assembled to create the applications. But you also have networking and security, management, telemetry, monitoring, and these are all services that are software defined. And traditionally, they also run as a virtual machine or as a container on the server. But the challenges with the software defined infrastructure is that it uses a lot of the CPU cores to run things. We see that often with the traditional software defined infrastructure shown in the middle of this slide, up to 30% of the CPU cores are being used just to run the infrastructure. And those 30% of the cores are not available to run the applications. So this is known as the software-defined performance tax. It's a tax because every server you deploy, 30% of the CPU power is not really being used for the applications. The answer is to move a lot of this infrastructure to the DPU. And we see on the right side, we have the infrastructure. It's still software defined, but it's now hardware accelerated by the DPU. So the DPU, all those tasks for networking, data movement, security, storage, and infrastructure management are now on the DPU hardware, where they're accelerated, and it no longer needs the CPU cores. So all or nearly all of the CPU cores can now run the applications, which is what the business really needs and where the business makes the money or serves its users or keeps its users happy and develops new products. All the CPU cores are used for that, and none of them need to be used for running the infrastructure because that's being done by the DPU. So here's an example of a DPU. This is the NVIDIA BlueField 2. And what this does is, this shows what's in it. It's a single chip which combines some very fast networking with some programmable ARM cores, as well as different types of acceleration engines that are useful for software-defined networking, security, encryption, data movement, as well as remote management. So we see inside this DPU, the BlueField 2 has almost 7 billion transistors. It has either 4 or 8 ARM cores, and these are fairly powerful 64-bit ARM cores that are programmable to run different types of management software, storage software, firewall software, or security agents, and we'll talk more about that in a little bit. And then it also has encryption acceleration for encrypting data on the storage or data on the network. And it has special offloads that will accelerate video streaming or accelerate content searching, accelerate storage, especially for NVMe over fabrics. So it'll support up to 5 million NVMe over fabrics IOPS. And it can virtualize the storage as well, which is really good if you have bare metal servers. Because with bare metal servers, you can still get management, security, network, software-defined networking, and things that you normally would have to run on containers or VMs, but you cannot run on those because a bare metal server does not have a hypervisor, and the tenants or users may not want you to run your management containers or networking containers on there. So all in all, the DPU, the BlueField 2 DPU, has the ability to replace up to 125 x86 CPU cores. So we take all the things that the BlueField 2 can do, including networking, security, storage, data movement, acceleration, video streaming, time synchronization. If you ran all of that on the CPU, it would probably take 125 cores. And again, these are cores that do not need to be used for this because the DPU is doing it, and you can use this to run your applications, while the DPU worries about running these things. And in addition, there's an interface called Doka for programming the DPU, and I'll talk more about that in just a little bit. That makes it very easy to program the DPU, just like CUDA makes it easy to program the NVIDIA GPUs. So some of the use cases for what can a DPU like BlueField accelerate? So first I mentioned software-defined networking. So with this, you can have a very efficient, very fast virtual router or virtual switch. You can also create a load balancer using network address translation. You could also have a stateful load balancer where you're able to balance traffic based on not just the layer 2 and layer 3 characteristics of the traffic, but looking at layer 4, 5, 6, and 7 parts of the network traffic as well, and making decisions based on that for routing or load balancing. We can accelerate networking for virtual machines and containers, so like overlay networking. And we can also accelerate, we have some special features that are optimized for telcos and network function virtualization, including some features specifically good for 5G wireless networking. On the storage side, use cases for the DPU include, of course, NVMe over fabrics, but also encryption of data. And again, the DPU can accelerate in hardware encryption of data on the storage or data on the wire as it's being transmitted, or both. So again, this is a very versatile use case of the DPU for encryption, and it's for storage as well as for network traffic, which could be for storage or for other things like web traffic. The Bluefield DPU also can virtualize network storage and make it look like local storage of any size, and we call that elastic storage. And that's really ideal for provisioning storage, again, for bare metal servers. The DPU can do compression and decompression, and it can also help accelerate deduplication of data. So this increases storage efficiency. On the security side, we'll have more detailed slides about this, but you can use the DPU to create a next generation distributed firewall, where parts of the firewall are running on every server instead of only at the network perimeter. And this is very important in a world where different threats are probably going to break in. You have to assume that threats or viruses have gotten into the data center, and you need to be able to protect every server. You can also run intrusion detection and intrusion prevention software on the DPU. And the DPU lets you do microsegmentation of the network and prevent or help stop DDoS, distributed denial of service attacks against the servers. And finally, the DPU helps create this hardware root of trust, where the DPU creates some security isolation and a separate layer of security that helps you ensure that the server has not been compromised. So for example, it supports firmware signing so that you know that the software and firmware on the DPU has not been corrupted, and a hardware boot where you can do a secure boot of the server through the DPU over the network, where it will help ensure that each server loads up the correct software or operating system or container management platform over the network and is not loading up a virus or a compromised operating system. So let's talk more about the security use case, because while the DPU can do many things, I think security is one of the most interesting use cases and a big focus for today's webinar. So on the left, we see a typical cloud server where I have a lot of security services, but if I run them on the server, they're all in software. You can see they're running on the CPU and they're using up many of the CPU cores. Again, these are CPU cores that should be running the application, but instead they're running the security services. So intrusion detection, next generation firewall, anti-malware, microsegmentation, etc., encryption. All of this can run in software, but it tends to be slower. It uses up a lot of CPU. And if the hypervisor or the operating system or one of the containers is hacked, there's a good chance the malware is going to turn off the security software or find a way to hide from the security software. So on the right side, we show, what if I use a DPU? I get performance isolation and security isolation. So now the CPU just focuses on running the applications. The DPU, the Bluefield, runs the security software and the SDN and the storage services, and we have this air-gapped isolation. So if anything infects the server, if anything infects, like there's a bad container or a bad the operating system gets corrupted, the DPU is running its own software and it's a separate piece of hardware, so it can resist the infection, it can detect and report the infection, and you, in many cases, stop it from spreading. So depending on what software, and Custodio will talk more about this in the webinar, but by running the security software on the DPU, it makes it much easier to detect threats that hit the server and contain them and prevent them from spreading. So that's what we mean by security isolation. So talking more about the cybersecurity, let's talk more about the specific use cases we have for the security. So first, as I mentioned, there is platform security. We help protect the servers or the platforms from hardware level attacks. So of course, there's the secure boot and there's the hardware root of trust. Again, every DPU comes with the ability to help sign and protect its own firmware and its own hardware from attacks. And then with this, you know the DPU is secure, and then it can help protect the server from attacks by enabling secure boot. Okay, during the secure boot and while the server is running, the DPU is able to help enforce security policies by filtering traffic, blocking visits, either attacks from known bad sites, or blocking the server applications on the server from going to known bad sites or going to sites which are known to carry malware. The DPU can also actually help perform packet inspection, deep packet inspection to microsegmentation to help detect or filter out attacks that are trying to come over the network. And it supports crypto acceleration, meaning that you can have much faster encryption of your traffic, making it harder for someone to intercept or steal traffic on the network going to and from that server. And the DPU supports this with both IPsec for IP traffic and then TLS, which is really useful for encrypting web traffic or high-level application traffic. So again, these are three of the use cases for security acceleration on the server with the DPU. And the DPU enables you to do this for every server instead of just doing it for a small sampling of the network traffic or for the perimeter of the data center. So two more security use cases. It looks like I mentioned it a little bit too soon, but the deep packet inspection. This allows the DPU to inspect the network traffic going in and out of the server and even inspect traffic between containers or between virtual machines on the same server. And that's something that a regular top-of-rack switch or a firewall at the perimeter cannot do. Those types of security solutions can be good, but they cannot see what's going on inside the server between the containers or between the virtual machines. And the Bluefield can, because it's in fact offloading the software switches with solutions like Open vSwitch or OVN, Open Virtual Networking, and it's offloading these so it can see and filter and the traffic between the virtual machines, between the containers, and detect threats that might be happening inside the server, as well as threats that are coming from outside, or if the server is infected, it can detect and stop that suspicious traffic. And when we say deep packet inspection, this means that the Bluefield can not only look at the headers and the source and destination address of the traffic, but actually look inside the packets, identify what types of applications might be using those packets, and determine whether or not those are legitimate uses or legitimate applications. So deep packet inspection could say that certain applications with certain connections are allowed to visit external websites, but other applications that are supposed to only be carrying internal traffic should only be allowed to go to certain internal servers. And if the traffic is going to the wrong place, or it's carrying the wrong content, Bluefield can report that and if necessary, block it. There's also an isolated control plane. So this means that if you have, again, a bare metal server, you can have the security control plane on Bluefield that's separate. And if you can do this even if you don't install an agent or a virtual machine on the server to run security, you still have a way to enforce your security policies and do security monitoring of the server. And these rules can be set or upgraded or modified with AI if needed to help detect new threats or previously unseen malware. So an important part of the security solution and the Bluefield DPU solution is Doka. Doka is a development platform that makes it very easy to write applications that run on Bluefield on the DPU or to integrate existing applications with the DPU. So again, Doka is for DPUs, kind of like what CUDA is for NVIDIA GPUs. And remember, CUDA makes it easy to take general computing applications and run them on GPUs without having to rewrite everything in a low-level GPU type language. Doka also lets you take existing networking and security applications and or storage applications and move them quickly to the GPU, or they might still run on a CPU, but they're accelerated. All their networking and their packet inspection, and encryption are accelerated by the DPU, even if the application continues running on the CPU, on the main x86 CPU. So DOCA was something that was announced last October and just released actually last week. So it's brand new and it's out there and it's now available. And again, we already have a lot of partners who are supporting DOCA and using it to integrate their security software or other software with the Bluefield DPU. So for example, on the platform side, we have Canonical, Red Hat, and VMware who are all working on this. On the security side, we have many security partners. 5 of them are listed here. So we have Checkpoint, we have Deep Instinct, Fortinet, Guardicore, Palo Alto, and actually also Custodio. And you'll hear more about from Custodio in just a few minutes. And then also we have services like Cloudflare, and we have edge management solutions like Juniper, load balancers from F5, storage solutions from DDN and others, Vast, Weka, Accelero. And these vendors are all integrating to support the Bluefield DPU. So again, this is a big, DOCA is a big deal because it makes it easy to move applications to the DPU or have applications offload their infrastructure work to the Bluefield DPU. And another big announcement from NVIDIA last week was in fact a security development platform called Project Morpheus. And this combines the power of the DPU, Bluefield, with the NVIDIA GPUs. And it allows security vendors to create a solution that is AI accelerated and it can be everywhere with the power of the DPU. So we have the ability to train these applications with DGX or HGX servers for deep learning and train them to recognize new kinds of security threats or train them to understand what is good behavior and what is bad behavior. And we can then do inference out there with EGX servers or other partner servers that are NVIDIA certified. And then the DPUs can be in every server to sense these threats and enforce the policies. So the DPU collects the data and it enforces the policies. The EGX servers are in the middle, are doing the inferencing. So they're taking the learning models and the AI models and applying them to the data that's coming from the DPU and telling the DPUs what to do. And then any new data, any new threats are going back to the core data center where deep learning does training to create better updated models. And those models are then pushed out again to the inference layer and then out to the DPUs. So this is the first cybersecurity framework, which allows you to have AI power and it's constantly adapting and changing and learning as it sees traffic and threats to detect new threats and stop malicious behavior, even if it hasn't seen it before. And this is a great platform for partners to build security solutions on using this NVIDIA framework. So to summarize, what we have with the DPU is the ability to maximize application performance and increase security while simplifying the management of large data sets. So, again, here's some examples with the Bluefield 2 DPU, regular expression checking, which is good for stateful load balancing or for security scanning of traffic, is up to 10 times faster on the DPU. Video streaming can be 15 times more productive or more efficient. You can have 15 times more video streams with the packet pacing feature of Bluefield. IPsec encryption can be done up to 50 times faster with the hardware in the Bluefield chip, than it can be done in software. Elastic block storage can be up to 30 times better performance than simple local storage. And then cloud overlay networking, if you have, again, containers or virtual machines, you're using something like NVGRE or Genève, the Bluefield can do this up to 10 times faster than doing it in software. And connection tracking, which is important for certain types of security or load balancing or virtual routing, can be up to 150 times more efficient with the DPU than doing it in software. So again, we see that these are all applications that are greatly accelerated by the Bluefield 2 DPU. And NVIDIA also announced last week that the future of the Bluefield roadmap or the DPU roadmap. So Bluefield 2 was announced a while ago and it just went generally available last week. So it's been out there sampling and now anyone can get it. The Bluefield 3 DPU was announced last week. It's going to be much more powerful, both in terms of regular processing as well as AI processing, and it will have twice the networking performance, and up to 5 times more computing power. And that will be, it's been announced, it'll be available around the beginning of, I think the beginning of 2022. And then Bluefield 4 is on the roadmap, and you can see it'll be even more powerful. It'll be able to have more regular processing capability, shown as the spec-in number. It'll have more AI processing capability, shown as the tera-ops or TOPS number, and up to 800 gigabits per second of networking, which is 4 times more than what Bluefield 2 has today. So you can see NVIDIA is committed to having a series of generations of DPUs that will be faster, more powerful, and more flexible, and able to support and accelerate a wider variety of data centers and applications. All right, so I thank you for your time. This is the end of the section about the DPU, and we now are going to go to, we go back to Alex and then to Custodio Technologies to learn more about a specific security platform solution.
Thank you, John. Now we shall now turn it over to Mr. Alvin Cheng from Custodio Technology to walk us through how his organization has benefited from the deployment of NVIDIA GPUs. Custodio is one of our software partners that is in Singapore. Alvin will speak about it. And we're one of the initiators that using already DPU for their application. So over to you, Alvin, please.
Thank you, Alex. Okay. Today I'll be covering what my company is doing, and basically our research and collaboration project with NVIDIA using the Bluefield DPU card. So basically this is actually one good example of the implementation of the isolated applications running on the security control plane, which John has just mentioned. Okay, some quick information about Custodio. Custodio was established in 2014 as an R&D center in Singapore. Our initial focus was to spearhead R&D projects in the challenging areas of cyber domains. Over the years, we have commercialized 2 of our R&D outputs. Okay, one of them is Custodio, our next generation investigation platform, which can also be used for tracking purpose, and the other one is Observer, an early warning data leak solutions. In 2018, we won the Cybersecurity Awards, and our solution is deployed and developed by our technical teams that actually comprise of elite cybersecurity experts from different cybersecurity domains, including malware reverse engineering and pen testing. Okay, before I talk about the collaboration with NVIDIA, let me introduce you to Custodio, one of our flagship products, okay, which is also the key building blocks for the projects. Custodio is built to support important functions performed during cyber investigation. This includes validate the occurrence of the cyber incidents, okay, to make sure that it's not something that is false positive. Second, to identify the scope of attacks. Okay, when we say identify the scope of attacks, it means basically what are the accounts that have been compromised by the adversaries, what are the machines that have been infected by malware, and also what are the protocols that has been used by the attackers or adversaries to actually do file exfiltration or even to actually download a payload to infect all the compromised machine further. Lastly, the analysts will also need to actually recreate the chain of events to understand what causes the incidents. Basically, this will include understanding what are the actions performed by the adversaries, what are the attack vectors they use, and all these other informations. All these are required in order, creation of the so-called the chain of events is important for us to improve the company's security posture. And in the case of APT attacks, this allows us to actually understand the actual cause of compromise, and from there to eliminate effectively all the so-called threats and tools that has been downloaded by the adversaries. Cyber investigation is never easy and comes with security challenge. During an investigation, a lot of work is carried out manually, okay, by the analysts. It's very painful, it's very time consuming. Not forgetting, there are different security tools that have been used by the adversaries, by the defenders to investigate the incidents. And there is a huge variety and volumes of data that have to be processed by the analysts. This makes cyber investigation process really time-consuming. And if you are talking about log analysis alone, it requires analysts to be looking at a huge volume of data and finding important data points to correlate. Okay, it could be within the logs itself or across different logs. And from there, you have to discover the new elements that is related to the attacks. And this is an iterative process. You have to look through logs again and again, eyeball through the logs, and find interesting things to further understand and connect the dots, understand what exactly happened during the incidents. Analysts handles different tools that are designed differently and require learnings. These machine-generated security findings do not provide a holistic picture of what happens usually. Okay, you take for example a malware reverse engineer so-called tools. You understand that they are generating reports that is very focused on telling you what the malware is doing and what is its capability. If you look at, for example, SIEM, they are actually focusing on telling you at that point in time what exactly happened. They never tell you what causes it to happen, what actually happens after that. Things are not holistic, in other words. Another challenge, there is a heavy shortage of cybersecurity personnel to handle increasingly sophisticated cyber incidents. Not forgetting, we are also facing at the same time adversaries that are actually having more automated tools to use and advancing the skill at the pace that we are not able to catch up in terms of the defender side of things. It means that in the future, we can expect a lot of attacks to be hiding under the radar, okay? Unless, I think the closest we can do is that we'll be using a lot of AI solutions to tell us anomalies. And from there, it's back to the analysts to actually understand whether things that happens. The validation still has to happen, okay? Validation. So it's still the basic process of understanding and analyzing what happens using security data generated by machine. In some cases, we also face a lack of reliable information due to insufficient logging or compromised evidence. This is possible because modern adversaries is using a lot of evasion techniques, okay, to reduce their footprint. For example, they are not using file-based malware anymore. They are using malware that get injected in the memory and run from there. Okay. Other techniques that the adversary is also using is actually anti-analysis tactics that actually compromise the evidence by playing around with time or by erasing entries inside the logs. So now, Cyvestigo. Cyvestigo is our flagship products which address all the security challenges I just mentioned. Cyvestigo comes with automations which collects event of interest from your existing SIEM or LMS. We correlate them and automatically discover new data points to form new queries, which will be sent back to the SIEM or LMS to fetch new data, and this process just repeats itself. So the result is an automatically generated graph which shows you what happens during attack in your network, okay? Or it could be even what happened during peacetime for people who's doing threat hunting. They may actually want to do some, make use of Cyvestigo to understand what is happening in their infrastructure and whether there is some things that need in-depth investigation or maybe have some effort to understand what is really happening in the background, which is not very normal. In addition, Cyvestigo automatically highlight to you the suspicious and malicious observation within the graph, which is the security findings will generate. Okay, Cyvestigo have built-in capabilities to detect tactics, techniques, and procedures mentioned by MITRE, or indicator of compromise. We call IOCs, which is actually mentioned or even provided by cyber threat intelligence platform out there. Okay, TTPs in layman terms means how the adversaries behave during the attack lifecycle. Okay, it could include making changes to specific registry key to reload their malware whenever the machine starts restart. IOCs refers to a list of IP address, port numbers, or file hashes, which usually the commercial CTI vendors actually sell as a service to tell you what are the related so-called bad IPs or file hashes you should be aware of when it happens or is observed within your enterprise. In conclusion, Cyvestigo visualize complicated security findings in a way that help analysts quickly identify the root cause of incidents and determine the scope of attacks. It supports the human thinking process. I'm showing you here is an example of a UI which the analyst will use to submit a query to Custodio. The analyst just need to actually enter a query title, select the log tabs that he's interested to query without knowing what the SIM is at the backend. You don't have to deal with the SIM or the LMS. You just look at this interface, put a checkbox to log tabs, indicate a time frame for query. Okay, usually we suggest 1 week backward from the time we observe that something bad is happening to understand what has happened. And lastly, one or more fields and field value pairs that become conditions that will be submitted for Custodio to the backend LMS or SIM to fetch the relevant data sets. Okay, this field and value pairs usually is easily retrievable from so-called machines like the SIMs or either EDR solutions. They usually flag up some security alerts, and all these alerts contain the information you require to make use of Custodio. Okay, this graph shows basically how Custodio actually presents security findings. It's very different from other solutions out there. Our aim is to actually simplify the presentation of complicated security findings, which allow analysts to understand what happened during a security incidents or not normal days, okay, in the network infrastructure. This helps to answer questions like what, when, how, why things happens, which is very important for analysts when they are doing investigations. This graph shows entity of interest. If you look at the legend here, basically, so the entity of interest includes processors, port, user, IP address, things, and computer names, for example. These are actually things that analysts or investigator will always look at when it comes to investigation. He want to know about each of this entity, how they behave, how they evolve, how they change the states along the way, in order to understand whether something bad has happened. Okay, this graph also shows what are the actions this entity of interest carry out. For example, a process is connecting out to external suspicious IP through a specific port, or maybe a process is starting up a child process which is not digitally signed. More in-depth information of each nodes and edges can be found by clicking on the nodes or edges in the graph, and the information will be displayed on the right-hand side of the UI. Okay, we understand that the graph can go really big with huge amount of data. Okay, and for investigation, where the investigator or analyst provide a time frame for investigation, which is very big. Okay, so that's why there is some useful features in Custodio to help the analyst to focus on the right thing. For example, interesting nodes or edges will be highlighted with I or T to indicate IOCs and TTP respectively. So when analysts see something on the graph with I or T stamped, they would probably want to take a second look at the entities or the edges. Okay, that is the action performed by the entities itself to understand what happens during the point in time. This graph also consists of also have a timeline at the bottom of the screen that allows the analyst to actually scroll and filter the event that is happening based on the time that is actually of focus. So he can play around the time and understand what is happening around the time period. So this powerful visualization allows the analyst to perform two very powerful so-called actions, which is timeline analysis and also link analysis. This is the most important things that affects the outcome of investigation. Whether your investigation is thorough or complete, or whether you have missed out any things, depends on whether you can actually get good answers from the security findings. And what we have in this graph actually provide you the answers to all this and find the right answers to actually decide the next step forward. Okay, the graph you've seen earlier gives you a high-level overview of what happened in the network or endpoint. We can dive deeper, just now as I mentioned, by clicking on the nodes or edges on the graph. What you see here is that by clicking on, for example, a nodes, or edges, you can see information appearing. Okay, on the left-hand side of the screen, as you see here, it will show you very information, low-level information that is very important for analysts to validate whether something really bad has happened. For example, it tells you where is the location of the file that is being executed. What is the hash values, for example, and what the computer names, and in some cases, it also provide you things like what is the account that is used to run the processes. Okay, it depends on really on the what you click on. You will have different information appearing on the low-level details panel to allow you to validate really whether something really bad has happened. Okay. Beyond that, basically the nodes or edges on the graph itself, when they mark with I or T's, just like I mentioned, IOCs or TTPs stamp, they will usually have a score associated with them. Okay, it's a score varies between 1 to 10. When you have an I, and for example here, if you have nodes that is chopped with an I, it shows you that this, for example, in this case, it's runner.exe. It shows you that this process is matching the IOCs. Okay, it means it is matching a suspicious or malicious file that's been published by someone. Okay, when you click on it, you will see that there is information that tells you the score of the IOCs. How bad is it? In this case, it's 3. Okay, it's telling you it's green, so it's suspicious, but not exactly malicious. So they also tells you basically the MITRE attack IDs in this case. Okay. So you can find more information about the so-called the nodes or the edges, which is stem with T or I. For example, in this case, if the MITRE ID is displayed, you can actually take note of the MITRE ID and just do a Google, okay, on the MITRE website to find out more information about what exactly is about the IOCs and TTPs. So comparing traditional investigation versus investigation using Custodio. Custodio actually significantly reduced the manual and tedious works performed by an analyst. You automatically correlate and relate fields of in different logs together and discover new interesting data points to provide you context of what happened. It eliminates the need for an analyst to learn SIM-specific query language to fetch data for investigation. Okay. It displays findings in a way which support timeline and link analysis. This is very important, and this supports the human thinking process and affects the overall outcome of the security investigation, which result in better decision makings. Lastly, it highlights bad or suspicious observation. That means TTP and IOCs, which I mentioned just now, so that you can plan what is the next step to perform. Okay, I will talk about the research collaboration with NVIDIA. Custodio is working with NVIDIA to combine the power and capabilities of both Bluefield DPU cards and Custodio into a next generation security solution for data center. This can be used for investigation purpose or for threat hunting in the data center. The expected outcome from the research is a solution which enables out-of-band mechanism to extract artifacts for investigation from host memory. When we talk about host here, we're talking about physical or virtual machines that is in the data center. Out-of-band is actually worth mentioning here because it's very important. It prevents the adversaries from knowing that they are being monitored. Okay, and it provides a means to extract very reliable artifacts right from the memory of the servers in the data center. So in this case, when you retrieve artifacts from the memory, even if the OS is being compromised, there is no way you can get fake artifacts that be manipulated by the adversaries, because you are getting actual raw data right from the memory, which the adversaries will not be able to tamper with. Out-of-band also allows us to focus on memory, which provide lots of real-time artifacts for investigation. In some cases, some of these artifacts are not even stored into the file systems, like the socket network connection details, which only is, some of these are actually on the fly created in memory, and it provides very new leads for investigator to actually investigate and understand, especially when the adversaries perform the operation using memories. The solution also automates the generation of security findings. By just now, what I showed to you with Custodio, you will know with the new information that is extracted out from the memory, you can make use of those to correlate and understand and visualize what happened in the data center, okay, and its servers. Okay, it's a very powerful concept out there, having the additional data sets that is extracted from memories using the DPU cards. This slide shows a very conceptual representation of how the solutions works. Okay, now it's in the research phase, and we have good success so far. Okay, on the top, you see that there is a server in the data centers. It's running a hypervisor. A lot of VMs run on top of it, and there is also a Bluefield DPU cards that installed. Okay, plug into the server hardware. There is an agent running, of course, on the DPU. This security agent is what we are creating now. On the bottom, you see there is a log repository. Okay, this can be a log management solutions. Okay, or database. We have a listener here at the bottom in the LMS that is going to listen and collect logs from the DPU agent. And once this logs is created by the agent, it is going to be pumped into Custodio or extracted by Custodio to actually generate the security findings. The flow is as such. Okay, the first step is to extract the artifacts from memory using the agent running on the DPU cards. Everything is out of band, and it's a line speed, very fast. In seconds, you will actually extract the artifacts of interest. Then the agent will actually be able to pass the artifacts extracted from memory. There is different, a lot of different memory structure to understand by the agent, and the agent is able to have the logics to understand the structure and to pass it out in the form of logs. These logs are actually very specialized logs that is created by this agent. You will not see any other agents that is running out there in the market that is going to create such logs. This is a specialized log created by our security agents that is running on the Bluefield card. Log is collected here, and it's going to be extracted and correlated by Custodio into the findings you just saw. Okay, I come to almost the last part of the presentation. The benefits. Oh, so basically these solutions that we are looking at provide a hardware accelerated solutions, okay, endpoint solutions to support incident response and threat hunting. It focuses on monitoring endpoint behaviors to detect malicious TTPs, okay, or that is happening on the physical host or the virtual host. It provides a quick way to do triage. If you're those who are actually doing forensic, they understand that actually dumping everything from memory is a very time-consuming and painful process. Okay, you will see a lot of data coming out from the memories, and a lot of them are not relevant for investigation. So by having solutions like a secret agent running a DPU card, we can do quick triage to actually take out artifacts of interest, memory structure of interest, to actually understand whether something bad has happened. Only when something really bad has been observed and validated will happen. Okay, then we can actually ask the agent to dump up the full memory. Okay. Lastly, basically this portion actually the hardware accelerated endpoint security solution also offloads security processing to the DPU. So now processing, we have agent running at line speeds. Okay, getting information at line speeds. Things are happening at a very fast pace. Our band memory acquisition allow us to actually extract useful artifacts from the endpoint. This actually allow us to have reliable artifacts for investigation, even when the OS or hypervisor are compromised. It allows us also to identify sophisticated attack using fileless malware, just as I mentioned just now, because no matter what, even if the file malware is not actually writing itself in the file system, it has to escape itself in the memory. So memory is the best place to see things happening real time and also in clear. Okay, so there's no way malware can escape detection or identification when it has to be run in memory. Hardware protected agent on the Bluefield is also actually protected. Okay, because just as John mentioned about, okay, there is a root of trust. Okay, because we have the built-in native capability of the DPU card to ensure that everything running has been securely signed, and all this integrity signature of this firmware and secret agent can be checked again during the boot time of the cards to ensure that it's not tampered with. Okay, I have some time for the quick video. It's going to be less than 2 minutes.
Alvin, we cannot hear. Maybe you need to shift to do something with your audio in the computer.
The sound over my side. Never mind. Maybe you just show without the sound.
No, it's okay.
It's okay.
Okay, Alvin, in any case, I would suggest to stop it because we are running over time. So maybe.
Okay, I will stop here so that we have some time for question and answer.
Okay, so in any case, so first of all, thank you very much, Alvin, for presenting such a compelling use case for DPU. And from this use case, we have learned the DPU, what is the advantage of DPU with the Custodio software and how we saw the benefit. And this is the end of our sessions today. We have time to Q&A. Now, if you're interested to learn more, so please contact me, okay, in my email, and I will forward the right question to our salespeople, and they will contact you directly. Okay, another thing that, you know, we are ready for doing some POCs or demonstration with Custodio together with the DPU. By, let's say, by end of May or June, we can have some, if we can have some accounts to do the demonstration, you are welcome also. So you will contact with our sales, local sales representative. That's it. So I see that there are some Q&A, so we will answer the Q&A questions.
Yes, may we have John to answer some of these questions from the Q&A chat box, please?
Okay, so.
Sure, actually, so some of the questions were about what can you run, what software is available to run on Bluefield or is integrated with Doka. And I wanted to call out that two of the solutions that maybe are not a GA, but they publicly announced that they're working on the integration and testing are VMware and Red Hat. So VMware is working on running their ESXi hypervisor on the Bluefield DPU. And something I think known publicly as Project Monterey. And there's some blogs about it. I think they're both VMware blogs and NVIDIA blogs that you can find pretty easily that talk about that. And it's not available yet, but it is something that they've already have had demonstrations of it between NVIDIA and VMware. And I look forward to that coming out. And Red Hat has also published a blog. I think in one of the answers I posted a link to one of their blogs where they've already been testing running either RHEL or OpenShift on the DPU, and they are again. So I think they may hear more about that or more news about that coming up pretty soon at Red Hat Summit. So that's two great examples of large vendors that are already supporting. They're integrating with the Bluefield DPU and have written about it publicly.
All right, I think we do have one question from our attendee. Can Cyvestigo produce false positives?
Alvin, for you.
Yeah. So Cyvestigo actually rely on the data, and we connect it in the so-called in a way to actually shows you what happens basically. So false positive, we don't actually because we are not relying on AI to actually tells you what happens in the network. We really rely on what is recorded inside the logs itself, and we connect it to show you what exactly the log is telling you. So in other words, we are not so concerned about false positive in cybersecurity.
There is another question from for you, Alvin. It looks like Cyvestico is doing EDR faster and not really doing EPP better for prevention security rather than detect response.
So EDR solutions out there does do a bit of the investigation on the memory portion to understand whether sensitive memory structure have been touched. In the aspects, we are doing something similar, but remember the EDR solutions require an agent that is running on OS that is vulnerable to compromise, okay, like kit attacks. So with what we are having here, using the DPU cards, there is no way the attackers can actually compromise the DPU because it is air gaps compartment. I hope I answered the questions.
Thank you, Alvin.
Okay, sorry, and one last question is regarding I see that John is answering if the Bluefield is functioning also a regular NIC. So John, maybe you can answer it online.
Yes, I was typing the answer, but I'll go ahead and answer it verbally. The Bluefield includes a smart NIC capability inside. In fact, the current Bluefield includes everything that's in the NVIDIA ConnectX 6 DX network card is also included in the Bluefield chip, plus the extra security and the ARM cores and the PCIe switch and the DRAM controller. So yes, the Bluefield can support 1 or 2 ports of networking, typically at 25 gig, 50 gig, 100 gig, or even 200 gigabits per second.
And also if it supports PCI 3, there was also one of the questions.
Right, the answer to that is it works fine with PCIe Gen 3 servers, but it won't be able to do the 200 gigabits a second of networking with the PCIe Gen 3. If you have a PCIe Gen 3, the most you can achieve with 1 port is 100 gigabits per second, and with 2 ports, you could get about 112 or 100 and maybe 120 gigabits per second of throughput. To get the full 200 gigabits per second of networking, you need a server with PCIe Gen 4.
Okay, thank you, John. Okay, so over to you, NVIDIA event.
Yes, we have one more question from the audience. I think this is a live question they'd like to ask. So maybe we can accept this and wrap up a presentation for today. Let me just invite the person to ask the question.
Hello, can you hear me?
Yes, you're good.
Hi, I'm Sheikh from right here in Singapore. I've got a question for John. It's just a brief question. Okay, if the Bluefield DPU includes ARM cores, is it meant to replace x86 CPUs in servers?
Generally, no. It's not meant to replace the x86 CPU to run the applications. It can replace, and it's very good at replacing, some of the x86 CPU cores for running the networking or security or data compression or data encryption, because it can do that much more efficiently and faster than the x86 CPU cores. But you're not going to get rid of the x86 cores. You still would keep those to run the application. You just have more of those cores available to run the application.
Thank you.
Thank you, John. I think we've come to the end of the webinar. Thank you so much for all our panelists as well as Alex for sharing the insightful discussion today. So if you do have any questions to the attendees, please reach out to Alex via email. His email is on the screen right now following this webinar. We will also be sending you the recording from today's session, so hang tight for that, and we'll hope to see you at our next webinar soon. Thank you everyone for joining us today. Have a good day ahead.
Thank you. Bye.